Assalamu alaikum everyone. Welcome to the course of Digital Logic Design. Today we are starting with the interesting topic of sequential logic circuits. Before going into its details, we need to understand what is the importance of it. As we know that daily we are using a lot of electronic devices. They range from handheld devices like our mobile phones, digital cameras, personal media players, personal computers, to a lot of consumer devices like digital refrigerators, washing machines and many more. All these types of devices have to do some sort of sending, receiving, retrieving and processing information, and that is why we are studying sequential logic circuits. In next couple of lectures we will be going into a lot of details of sequential logic circuits. So fundamentally these devices have some electronic circuits, and these electronic circuits can be divided into two types. One is the combinational logic circuit and another one is the sequential logic circuit. Combinational logic circuits have outputs which completely depends on its inputs, and there is no storage involved. Their examples can be given by adders, subtractors, comparators, encoder and decoder, multiplexer and demultiplexer, also called mux and demux. So these are the examples of combinational logic circuits whose output only depends on what input is applied at their inputs. On the other side we have sequential logic circuits. In sequential logic circuit, output depends on what are current inputs as well as the past inputs. So it is combinational logic with storage involved in its feedback path. This is the block diagram of a sequential circuit. So here output depends on the whatever input is applied and what is the internal state of this sequential circuit. So internal state is defined by storage of this circuit. So we can also refer it as the internal state. And this could be a flip-flop, either a single flip-flop or multiple flip-flop, depends upon our application. So flip-flop is a bistable device which stores one bit of information. It can store either 0 or 1. So the internal state could be referred as that it is storing 0 or 1. Okay. Now the question arises that how this internal state is defined. Keep remember that internal state is a function of what sort of inputs are applied and what was its previous state. Fundamentally, current state of the circuit is defined by what types of inputs we have applied and what was its past state. Okay, so finally keep remember that sequential circuit is the function of inputs, outputs and internal state, because internal state will always depend on what value is there at the output, which depends on what value is at the input and the value that is present at the storage previously. Now the question arises that how internal state is changed in the sequential circuit. For this, we need to understand that sequential logic circuit have two types. One is synchronous type and another one is asynchronous type. Asynchronous type, internal state is changed at any instant of time in the order of input change. So how input changes, output will completely depend on it. In these type of devices, the storage element of the sequential logic circuit are basically time delay devices, which actually provides us the propagation delay. And this propagation delay actually gives the storage element to the sequential logic circuit. So this is actually complicated to design, and for the time being our focus is on the synchronized type of sequential circuits. In synchronized type of sequential circuits, we have internal state which changes only at the discrete instant of time. Here we have a clock generator which provides us a periodic form of pulses. So a clock can be given as a periodic waveform of pulses. This waveform has certain properties, such as it has signal high levels and signal low levels. It has edges such as changing signal from high to low and from low to high. So storage elements basically change its state when there is arrival of each pulse. And based on it, we have two types of storage elements. One is latches and another one is flip-flops. Latches responds to the signal level, either the signal is high or low, while flip-flops respond to the either signal is changing from low to high or it is transitioning from high to low. So this is called a negative transition, while this one is called a positive edge transition or positive transition. So the important point is clock pulse will tell us when computation will occur, and the signal tell us what type of computation will occur. So for example, in this type we are adding 1 0 with 1 1, and the clock pulse will tell us when computation will occur. So for example, if computation occurs at only the high signal level, so whenever the clock goes to active high, these numbers can be added. Otherwise, these numbers will not add with each other. So clock defines when computation will occur. Thank you.